Hello, everyone. So my name is Joseph Ansong. I'm in the Department of Mathematics at the University of Ghana. So I'll be giving you a lecture on the introduction to ocean modeling. I will do a short talk as well, and I will talk give a brief talk about my research area so that you get to know my interest. Okay. So in this talk, I'll be give an introduction about different approaches to studies in the ocean, and then I'll spend a lot of time on motivation, why it's important to model the ocean, and then I'll take you through the modeling process. In other words, what do modelers go through to come up with a model? Okay. And then I'll show some simple cases or examples, and then some challenges. At the end, I'll end with where you go from here. Okay, after this talk, if you want to try to study or to do some modeling, where do you start? Okay, and so this lecture is basically going to be an introduction. It is not one of the lectures that will take you step by step through a particular model. Okay. So, as you are aware, there are various ways you can study the ocean, and one of those ways is, of course, you jump on a ship and then you head out to sea to a particular part of the ocean, and then you launch your instruments, they gather information, and then from there you study a particular process, for example. Okay, so observational oceanography is one way by which you can study the ocean. It's probably the traditional way of doing it. And there is satellite oceanography. The satellites orbiting the Earth, of course, gather information about the land and also the oceans. And from the data that they gather, you can sort of study things like the sea surface height, sea surface temperatures, and other interesting stuff, chlorophyll levels. And so that's satellite oceanography, and it is one of the perhaps the more recent approaches to study the ocean as well. So that's one way. If you're interested in chemistry, there is chemical oceanography as well, where you can go to the ocean, take samples, and then study the chemistry of those samples. If you like, the chemical composition, the ions, the levels of pollutants in a particular sea, and all of that. So that is chemical oceanography, and then some of our instructors will be talking about that. Of course, you can also study the ocean via hydrography or coastal morphology, right, where you study the bathymetry of the ocean. You can map it out. This is very helpful even for modelers. And then, of course, you can study about all this erosion that is happening along our beaches, and hopefully, right, come up with solutions to how we stop this. So this is another approach by which you can do oceanic studies. Of course, sometimes when you say you are studying the ocean, people immediately think fish. Of course, fishing and studying the fish is part of oceanography. So of course, you can go into this as well. Angela often gives a very good talks on these fishes in the ocean. So Angela is, by the way, one of the instructors, I think. There is also the oil and gas in the ocean. So that is part of oceanography as well, that you can study. There are the minerals at the bottom of the ocean that you can study. So oil and gas is all part of that. And then perhaps getting close to what my interest is there is lab experiments which you can also use to study some processes or dynamics in the ocean. Okay, so you can basically set up a laboratory tank, fill it with fluid, and then study some aspect. If you like, you can study the surface waves, for instance, or you can study the internal waves, which are waves that are within the ocean. Okay, so this is just a snapshot of an experiment I did many years ago when I was doing my PhD. Okay, so we set up a uniform fluid, and then below here is a stratified fluid. It's linearly stratified. The density is increasing linearly as you go down. and what you do is you launch a plume. So this is heavy saltier fluid. You inject it, and then once the plume hits the interface here, because this is stratified, the lower layer is stratified, you can generate internal waves which will propagate it down. So I'll show you next a short movie of that. Okay, so you launch the plume, it hits the interface. Below here, it is a stratified fluid. Because of that, you have waves that are generated and they propagate down below. And the motivation was, if you have a storm that disturbs the surface of the ocean, all right, then the lower layer of the ocean, which is stratified, you can have waves that are launched. And so if you know anything about a storm on the surface here, can you predict the characteristics of the waves, the internal waves that will be generated? On the other hand, if you flip this, if you flip it upside down, for instance, upside down, then you can think about a storm within the troposphere that is hitting our stratosphere, and then that storm is able to generate waves that propagate into the stratosphere. So the question is that if you know anything about a storm in the troposphere, can you predict the internal waves that are generated in the stratosphere? Okay, so that was one of the motivations for this research. Again, this was many years ago. So you can use lab experiments to study some things in the ocean as well. But for today, I'll be talking about modeling for the most part, and the process of ocean modeling. Okay, this image is taken from the MIT GCM website. I'll talk about that later on. Okay, so I often like to start by asking this question, that what is an ocean model? Okay, before we launch into the modeling process and all of that. Okay, so, and I like this definition by Dr. Stephanie Waterman. Okay, you would get these slides. Okay, these slides will be posted. So if the word is missing or something, you can see it in the slides. So this is Stephanie Waterman. She defines an ocean model as a representation in the form of equations, computer code, describing physical processes of our understanding of how the ocean works. Okay, so basically it is a representation because it's not, the real thing. And we are representing it in the best possible way that we understand how things work in the ocean. And the best way we can represent things, okay, is through using mathematical equations, of course, and computer, translating those equations into computer code. I won't be talking much about the coding aspect of it, but I will touch on the physical processes, representations, and then the equations that you have to be familiar with if you want to get into modeling the ocean. Okay, and so some of the processes. So let me just do this, so that some of the processes of in the ocean that we want to model, of course, are the ocean movement of currents, the dynamics that is happening both horizontally and vertically. There is exchange of energy between the ocean and the external sources, for example, the atmosphere. There is exchange of energy, radiation, precipitation, evaporation. You have winds and river runoffs. So these are all processes you want to model. Okay, so these are physical processes of interest. Then, of course, you have the three-dimensional mixing and dissipation processes that are happening within the ocean as well, that we are interested in. Okay, and so these are some things that we are interested in. So the most important question now is that why is it important to model the ocean? Why is ocean modeling important? Okay, so that is one question that the next few steps will take us through that. All right.